I'm so happy to introduce Andres Chang. He's an artist and he's a researcher at Greenpeace USA. And he's here to talk about his new book he just published. It's called A New Plan to Capture Greenhouse Gas. And so I'm so happy to have you, Andres, and I'll let you take it away.
Before I jump into it, I'm going to let Vasiki, who's another member of Science for the People, talk a little bit about Science for the People. They published the book and are also co-hosting the event. It's an activist group I've been part of for a few years, so I want to provide that space before jumping in.
Thank you so much, Andres. So just to tell you a little bit about Science for the People, we've been active between 1969 and 1989, and then revived again since 2018. We're an activist organization of scientists, educators, writers, and artists who are committed to the radical and democratic transformation of science and society for the benefit of humanity and the planet. Science for the People also puts out 3 issues of the print magazine each year. So signing up as a subscriber is a really great way to stay plugged into how radical scientists aim to understand and to transform the world. And with that, and with no further ado, I'll pass it back to Andres.
Sweet. Thank you so much, Alexa. Thank you, Vasiki. Just some quick housekeeping before jumping into things. I would suggest that folks mute themselves for the first part. I'm going to start with a talk, maybe about 30 to 40 minutes, and then jump into a Q&A. And also, I will be pulling some slides up directly onto my screen, not through sharing my screen. And what that means is that if you want to see them, you should select speaker view. And to do that, you can just move your mouse into the top right corner of the window, where you might have a grid, you might already be on speaker view, and speaker view is at the top. So then you'll be able to see the content I'm sharing, which will include drawings and some slides. So I'm really excited to be talking about this new book, A New Plan to Capture Greenhouse Gas. I published it with Science for the People magazine, and it's been a long time in the making. So I also want to give a quick shout out to the publisher, Calvin Wu, my lead editor, Alex Adams. I want to thank Ansar Fayazuddin, who's on this call, and we had lots of back and forth, emails, Zoom calls to sort of flesh out some of these ideas, and one of our conversations is transcribed in the book. And of course, thanks to Alexa, Ellie, and Vasiki for helping put on this talk. So with that, I will get into things. The project, A New Plan to Capture Greenhouse Gas, is really a reminder that to overcome the climate and ecological crises that we face, we really need to organize to dismantle fossil fuel empire and fundamentally change the fabric of our society. Of course, there are many different ways to tell that story and different ways to arrive at that conclusion. But the one that arrested my attention when I got started working on this project several years ago was the story of CO2 disposal. CO2 disposal is one of many solutions that's been dreamt up for dealing with the climate crisis. It involves capturing CO2 and disposing of it away from the atmosphere like waste. It can be applied at a point source like a power plant.
Take this out, can't you?
It can be applied at a point source like a power plant, thus preventing the source's emissions from entering the atmosphere at all, or it can be used with CO2 that's been drawn down from the atmosphere, which effectively reverses emissions after they've occurred. Now, I know some of you are more or less familiar with this engineering concept because that's really what it is. It also goes by different names. There are different sort of subcategories of CO2 disposal. Folks refer to it as CCS sometimes, and it definitely has overlap with CO2 removal. But I prefer the term CO2 disposal because it draws attention to the fact that this is really a waste management approach to dealing with the climate crisis. But let's just jump into some real world examples here. The Boundary Dam Power Station in Western Canada opened more than a half century ago. It grew from 1 to 3 to 6 turbines that are all used to generate electricity. And these are coal-fired turbines. They convert coal-fired heat into the power that runs into homes. And in just one day, a plant like this produces enough gaseous CO2 to fill several Canadian football stadiums. In fact, most coal-fired power plants like Boundary Dam are so high polluting that the provincial government in Western Canada ordered for them to all shut down by no later than 2020. But this specific station, Boundary Dam, is still hanging on. Why? It's been outfitted with technology that separates out CO2 and other pollutants before they exit through the smokestacks. It's a bit of a unique project. It's actually the only coal power station in the world that currently uses this kind of technology. But there are 30 other large-scale CO2 disposal projects that are in operation that are otherwise similar. They're linked to cement plants, chemical plants, and refineries, all sources of massive amounts of emissions in a relatively confined location. And what these all have in common, allegedly, is their size, but also that they avoid emissions by trapping CO2 that would otherwise be vented into the atmosphere. That's what their proponents will tell you. Then there's direct air capture, a new technology that seems to be taking hold. Direct air capture works by sucking CO2 out of the atmosphere using giant fans effectively. It's a pretty energy intensive process, as you can see in this diagram. There are several different steps involved. There are filters behind the fans, and once those filters get saturated, they need to be heated to prepare the CO2 for disposal, and then they can be reused. But these direct air capture plants, the ones that exist today, are not like Boundary Dam. They're much, much smaller. And as of today, there are only 18 direct air capture plants that are functioning around the world. All of them are small scale, and actually only 2 of them are used for CO2 disposal in the classical sense. The others recycle that captured CO2 into synthetic fuels and drinks carbonation. So to give you a sense of scale, this is the largest CO2 disposal plant that's operational. It's a Climeworks plant in Iceland, and it's pretty puny compared to the size of a power plant like Boundary Dam that we saw earlier. So just interesting to keep that in mind. Nevertheless, excitement for CO2 disposal seems to be at an all-time high. There's been an explosion of corporate net zero commitments over the last few years, which seems to all but guarantee that demand for technologies like direct air capture will increase. Many companies have been slow to unveil detailed plans, but Google, Facebook, and Stripe announced last year that they would be committing $925 million to scaling up carbon removal through 2030. As one might expect, several CO2 removal marketplaces have emerged onto the scene, and this whole space seems to be scaling up in real time. But public investment prospects are perhaps even more promising. And this is actually pretty new. This is much newer than the drawings that I'm going to show you. But last year, the US launched a $3.5 billion program to speed development of carbon removal tech. And much more importantly, the government will be rewarding companies with $180 in tax credits per ton of captured CO2 because of the IRA, the Inflation Reduction Act. That's a massive, massive incentive. And as you can see in this diagram, that incentive is expected to increase the use of carbon capture by 2030, according to techno-economic models that I'll be talking about a little more later. And that's an enormous increase over the amount that occurs in the US today. However, for all of this hype, there are some really big issues to deal with in CCS, and I think it's still not chalked up to all that its proponents claim that it is. Unfortunately, the issues with CO2 disposal are downplayed or ignored by the mainstream narrative. And in fact, they only became clear to me once I embarked on my own research. And I'll start talking about that so you have an idea of where I'm coming from. My obsession with CO2 disposal began at work. I worked at a UN-backed climate program called the Science-Based Targets Initiative for 4 years. And eventually I would find myself leading the initiative's cross-sector research. Over the years, I spent many hundreds of hours working with computer simulations that were intended to guide climate and policy. These involved models of the global energy and land systems that were used to churn out cost-effective pathways for how global climate goals could be met. In some way, these models and these scenarios were the backbone of our initiative, which sat squarely at the nexus of science, policy, corporate sustainability, and finance. When I started working at this initiative, CO2 disposal and CO2 removal were not really part of our work. This was before net zero exploded in popularity around 2020, right? And also our work was focused on defining corporate emissions reduction targets that was pretty separate from all of the hubbub that was happening in the offsets market and this sort of techie space. But nevertheless, the idea of CO2 disposal was present in the periphery of my work. And there were 3 observations I had that ended up turning my interest into more of an obsession. What struck me first was realizing the immense scale of CO2 disposal in these computer simulations. Remember, these simulations are intended collectively to guide policy, and many of them depict more than 10 billion tons of CO2 disposal a year by 2050. That's a 5,000 times increase from today's level. To put it in perspective, the last chart, which shows how much the IRA would incentivize, was a 13 times increase in the US. We're talking about a 5,000 times global increase. And I've also just put an X on this chart where CCS levels in 2035 will be if the IRA proceeds as planned, according to modeling that's been done at Princeton. So this is a massive, massive increase in reliance on CO2 removal and CCS to actually achieve climate goals. What struck me next, and I don't think most people think about this when they are thinking about CO2 disposal, is the irony of invoking pipelines to solve the climate crisis. Because as you scale up this solution or this system, pipelines are needed to carry this captured CO2 to its disposal sites. Pipelines and other forms of infrastructure as well. Today, looking at 30 large-scale CCS programs around the world, projects around the world, this is not at the forefront of people's heads because those projects are cited in such a way as to reduce costs. So they're cited in a way that doesn't require this kind of interstate CO2 transportation. But you can imagine that if we're scaling this kind of technology up to billions of tons a year, the infrastructural requirements are huge. And historically, pipelines have been a vehicle for land theft and water pollution, in addition to carbon-dense fuel. Some of the biggest protests that we've seen over the last decade have been around pipelines. So the idea that we can sort of presume that the build out of this infrastructure will proceed in any way smoothly is extremely short-sighted and just flat out wrong, not to mention unethical and unjust. But what kicked me into investigative research mode was learning that certain types of CO2 disposal were illegal under international law until energy industry proponents who viewed this as hardly an inconvenience decided to revise the law. And it all dates back to a relatively obscure treaty called the London Convention. So this is where the first drawing series starts, and it's a bit of a surprising starting place. By the early 1970s, vast amounts of waste were being dumped into the ocean every year. Environmental activism was also on the rise, and so logically, ocean dumping became an increasingly visible and viable public concern at that time, especially because some of this waste was nuclear. We can only guess exactly how much, but EPA records indicate that more than 55,000 containers of nuclear waste were dumped into the Pacific Ocean between 1946 and 1970. But the bulk of what was and still is being dumped into the ocean was more mundane than that. Billions of tons of oil, dredged materials, and garbage. World governments were soon in agreement that something needed to change. So in 1972, at a UN-convened conference, they drafted a treaty known as the London Convention, which became one of the first global treaties to protect the marine environment from human activities, including oil, but it made it illegal under international law, that's the big piece, to dump or burn industrial and radioactive wastes at sea. It was enacted in 1977. And this treaty wasn't entirely effective, but it was still a major environmental achievement in some ways. And so things stood there for around 20 years. The agreement was further strengthened in 1996. A new piece was added onto it called the London Protocol. And this was different from the London Convention, which focused on specifically banning radioactive and nuclear waste. The London Protocol banned all kinds of industrial waste disposal at sea, except for a whitelist. So in the first version, basically called out several things that you couldn't dump. The new version banned all kinds of industrial waste dumping except for excluded categories. And according to the scientific advisory body to the United Nations at this time, CO2 was prohibited under that definition. So this meant that dumping CO2 point blank into the ocean, which I'll talk about later, was made illegal under international law, but also certain kinds of subseabed geological storage where CO2 is buried underground or mineralized into rock, which is a more classical form of CO2 disposal, or at least that's what we're more familiar with. That was also in some cases illegal. So this could have thrown off the niche field of CO2 disposal research that was quickly picking up steam in the 1990s, but it didn't. This idea of CO2 disposal was little more than an engineering concept, but a small and quite well-supported research community began to grow around it in the 80s and 90s. It was supported by powerful interests in government and heavy emitting industries, and they were basically not about to let an environmental treaty get in the way. So rather than accept the global agreement as it stood, parties to the London Protocol, at the behest of industry interests, decided that they would just revise the international treaty. And they had plenty of muscle to fall back on in this campaign. The US, Norway, and Japan were especially gung-ho about ocean-based CO2 disposal at this time. The International Energy Agency, which is a powerful intergovernmental organization, insisted that the treaty could be circumvented. And so that all sort of helped. And of course, corporations had a heavy hand in the CO2 disposal research that was happening at the time, and they were drumming up its potential as a climate-saving technology. And of course, in that same time span, big oil was spreading climate misinformation, and countries like the US took hardly any steps to crack down on fossil fuel use. I conducted most of my research into this history through primary documents, digging through treaty drafts, meeting notes, technical studies, and the like. I annotated and underlined these materials as I read them, and soon I found myself drawing on top of them as well. So the London Convention drawings are a series, and the drawings themselves, there are 10 of them, form a timeline that starts at the original treaty when it was adopted in 1977, and it stretches pretty much all the way out through today. So I'm actually going to share some of these drawings, walk through them a little bit, but for this first drawing I want to actually share it with you all and ask you what it is you see in the drawing and how you think it fits into the story, because part of the goal of these drawings is to turn the viewer into a detective, so you can enter into this story the same way that I did. So I'm going to make this full screen and then ask you all what it is that you see, if you can place it into the context of the story. If you want to, you can raise your hand. The Siki will call on you or put it into the chat. All right, we see waste dumping into the ocean, sludge, spillage of waste, seeping out waste. Yes, there is this associative drawing on top, and this is immediately what the research and digging into the treaty brought to mind for me. I actually didn't realize how big of an issue ocean dumping was before diving into this research process. But below the drawing as well, it's a little bit hard on a screen, but if you have the book, you can actually dig into some of the text. And this is this is a page from the original treaty, which was enacted in 1977. And it expresses the overall intent and rationale behind the agreement, which very much was the fact that the oceans were being used as a dumping ground for this kind of radioactive waste, which probably would have been dumped in containers like steel barrels. But also, as I mentioned earlier, just lots and lots of oil and dredge materials being dumped into the ocean point blank. This second drawing in the series is also pulled from the initial treaty, and it lays out that contracting parties, so the countries that signed on, pledged themselves to promote measures to protect the ocean from pollution caused by hydrocarbons, including oil and their wastes, as well as radioactive pollutants, agents of chemical and biological warfare. So to me, this made the link explicit that even from the very beginning, this treaty had something to do with the fossil fuel industry. And even in the 70s, offshore drilling was a big issue, right? Several years earlier in 1969 was actually the third largest oil spill of all time, which is a blowout near Santa Barbara. So this story does go on for longer than many of us might think when we're considering CO2 removal as this fancy new technology. This third drawing overlays a submission that Greenpeace International made to the scientific group of the London Convention in 1999. So it was at this point that the London Protocol had been adopted, and it was understood that that banned at-sea disposal of CO2. Now, parties to the London Protocol were debating what to do about that. And Greenpeace's testimony basically highlights that the current pace of research and development in this research field threatened to overtake proper consideration of environmental, legal, and ethical implications, and that source reductions of CO2 should be the clear priority, even at this point in 1999, when CO2 disposal was clearly prohibited. The next drawing is a sort of post-mortem from a report that describes what ensued next after Greenpeace's submission. An amendment to the treaty was swiftly passed, and there was very strong political support for CO2 disposal and, quote, the benefits of geologic storage in the context of expectations about rising levels of CO2 emissions and continued dependence on fossil fuels. So Greenpeace International was pretty much entirely correct that the sort of political support for this, this idea really seems to have overtaken the ethical, legal, and environmental considerations that should have been at the center at that time. The fifth drawing in the series is done directly on top of the actual amendment to the London Protocol. And there's a special irony here, because the justification for making this amendment was concern, quote, serious concern for the implications that climate change has on the marine environment and ocean acidification. So the idea was, we actually need to revise this law to make CO2 disposal, specifically geologic sequestration underneath the seafloor, legal, because climate change poses such a threat to oceans. And I'll skip to the last drawing in the series here, but it kind of sums up my reflection on all of what I dug up and brings it to today. And this is a note that I wrote down, which says, quite simply, yesterday's power brokers still insist that CCS will save us 10 billion tons of CO2 pumped underground every year. So that was the first drawing series. And of course, my research didn't stop there. I really wanted to better understand how CO2 disposal amassed so much political support, because it certainly didn't come out of nowhere. I suspected that the scientific community played into this story somehow. Ever since my obsession began, I had been curious as to how techno-economic simulations used to guide policy came to rely on billions of tons of CO2 disposal. And learning that this was initially prohibited, at least in certain ways, by the London Convention grew my suspicion even further. One of my first interesting discoveries was that MIT hosted an event called the Third International Conference on Carbon Dioxide Removal in 1996. It was co-organized by Howard Herzog, which is a name that I just kept seeing over and over and will appear again in this story. But in this conference, more than 250 delegates from 26 countries attended. There was an extensive program of talks, panels, poster sessions, exploring the idea of CO2 disposal. And among them were sessions focused not just on carbon capture with geologic storage, where the CO2 is mineralized underground, but also direct ocean CO2 disposal. Direct ocean CO2 disposal has fallen out of fashion, but it's exactly what it sounds like. And in the 90s, it was being taken seriously by this research community. The idea is that you can take this captured CO2 and just dump it point blank into the ocean. There were specific methods dreamt up for how you would go about direct ocean CO2 disposal, and they sound like pure fantasy. Learning about them really hammered home for me the dissonance between what was happening in academia and in the real world. So the Green Man drawing series really runs with this idea. The drawing series tells two different stories about what was happening simultaneously. On one hand, the emergence of this CO2 disposal research community, which stemmed from very techno-solutionist roots in the late 1980s. And on the other hand, the story of the failure to actually deal correctly with climate and environmental issues over that same time span, despite clear global warming evidence and public concern. There are different layers to the drawings, similar to in the last series. It's a shorter series, it's only 4 drawings. But in the Green Man drawings, there's an underlying set of technical studies, an overlying set of news clippings, and then a colored pencil drawing of a face called the Green Man shining through. And the technical studies, as you'll see, move from global to micro scale. So there's sort of this telescoping effect that you'll hopefully notice. So this 4-part series starts with a study by the EASA engineer Cesar Marchetti called How to Solve the CO2 Problem Without Tears. It's founded on the unquestioning assumption that gas will be the predominant energy source for the next 50 years. And so the proposed cure that Cesar Marchetti has nothing to do with cutting fossil fuel use. Rather, he suggests injecting the emissions underground. This study was published in 1988. And of course, this idea had really no grounding in reality, but his sensibility had widespread appeal to powerful Western governments and corporations. It played into this neoliberal worldview that careful engineering is really all that's required to understand and solve socio-political problems. And relatedly, it did nothing to actually challenge the status quo. To the contrary, it explicitly condoned ever-increasing fossil fuel expansion. On top of the drawing, the news clippings show two different events that happened essentially concurrently. At the bottom in the left here is a news clipping from James Hansen, a NASA scientist, testimony in front of the Senate in 1988. This was one of the first times that a scientist urgently rang the alarm to US leaders. And the second news clipping that you see here shows that just about a year after that, the US, with support from Japan, Britain, and the USSR, blocked the adoption of a global agreement that would have capped emissions and then required them to be reduced, a global agreement. And arguably, this is the closest the world has ever been to such a binding agreement on emissions or climate. The failure to actually pass policy that would grapple effectively with global warming was not limited to the international arena. Later in the decade in the US, domestic attempts to reduce emissions also failed. So the Clinton administration had pushed an effort for a BTU tax, which would have been an energy tax meant to reduce energy consumption and in that way start to deal with the global warming problem. It was a bit of a half-hearted effort though, and the news clipping here, the title of it is that lobbyists did a number on the BTU tax, and it was sort of revised so heavily that it really had no effect at all. There were industry exemptions everywhere. And the drawing in the background shows 5 different hypothetical options for direct ocean CO2 disposal. So what I was mentioning earlier about how this all seems so really pie in the sky and fantastical, you can see in this drawing a diagram showing different options. They include blowing CO2 into the ocean with a straw, basically, and letting it pool on the bottom. Dragging CO2 to be dispersed by tankers, and also freezing it into dry ice and then dropping that dry ice into the ocean as well. It's kind of wild. Fast forward a few years to 1997. This is, I think, another story on its own, and one that really caught my attention. Because until this point, most planned and completed studies of direct ocean CO2 disposal were purely hypothetical, right? This is the kind of study where you have an engineer doing some back of the envelope calculations about how much CO2 disposal is feasible in an energy system based on cost or geology alone. But in January of this year, in 1997, MIT's Howard Herzog penned a report to the US Office of Fossil Energy advocating for further research. And by December of that year, he was among the recipients of $4 million of funding to conduct direct ocean CO2 field experiments in Kona, Hawaii. And news of this experimental idea leaked to the press and to the community before the researchers intended. And the news clipping in the top right here, called Feds to Test Impact of Dumping CO2 into Kona Waters, was how most people found out about it. There was really swift community opposition and blowback. Folks in Hawaii were distrustful of mainlanders to start with. So the people who were fighting back against this project already didn't trust mainland scientists from the US. There were folks that were involved with the Hawaiian sovereignty movement who were part of the sort of Stop CO2 Dumping coalition that formed. Folks also opposed it because of the risks that it posed to the marine environment, at least the perceived risks. And the idea that this was a distraction from the need to actually phase out fossil fuels. And what you'll see in the news clipping in the last drawing is that the experiment was totally called off after years of back and forth between the researchers and the community. There were years of, this conflict went on for years, and eventually Howard Herzog's team pulled out. There were lots of permitting issues, and they actually tried to take it to Norway, and the Norwegian government gave them a permit to do the same experiment. But when they showed up in Norway, civil society organizations campaigned against the experiment again, and it was canceled for a second time. So this whole experiment, which would have been the first direct ocean CO2 disposal field experiment, was a complete and utter failure. But what's really quite notable to me is that despite that, Howard Herzog, who led the experiment, ended up accruing sustained support from Chevron, ExxonMobil, Shell, Saudi Aramco, Peabody Energy, Ford, General Motors, and other corporations in the following years. They basically joined with Howard Herzog at a consortium hosted by MIT, whose explicit goals were to influence policy and get policymakers on board with this idea, an idea that failed not once, but twice. So researchers like him, I think, are part of the problem. They have been allured, at least in part, by corporate sponsorship and professional fame, and by offering this sort of conduit to policy, it really does the whole movement a disservice. Well, I became convinced that CO2 disposal was never a particularly sensible answer to rising emissions because for decades it was used by governments and corporations as an excuse for inaction. Policies to conserve energy and reduce fossil fuel use were obstructed while CO2 disposal projects and research was awarded lots of money in support. And concerns over CO2 disposal are as relevant today as they were 20 years ago. For one, CO2 disposal is still undermined by its links to the fossil fuel industry. And putting our hopes in CO2 disposal means entrusting our future to some of the biggest, most evil corporations out there, because those are the ones that actually own this infrastructure and can wield it, unless we take a much more revolutionary and radical approach. It can absolutely still be used, CO2 disposal that is, to justify weaker near-term action as well. And we saw that in Biden's State of the Union a couple of days ago. He goes out on the stage and talks about how big of a crisis the climate change is, and then says, we're going to need oil and gas for the foreseeable future. And that kind of thinking is only propped up. The only reason it has even a modicum of legitimacy is this idea of CO2 disposal and CO2 removal. So this whole project to me underscores the importance of several monumental shifts in our thinking, which, to be honest, have much more to do with politics than technology. First, I think we need to be shifting from techno-solutionism to strategies for building power, because one of the predominant ways that we think about the climate crisis, or at least that the mainstream thinks about the climate crisis, is from a techno-solutionist perspective, where we will solve the problem by scaling up technologies and reducing costs or barriers to adoption. And that's really not enough. What we need to be doing is organizing for power, organizing for mass democracy and wealth redistribution, organizing to tax billionaires out of existence and making big oil pay for the damages they've caused, and for good jobs in the transition to a whole new kind of world. Second, we need a shift from individualism to mutually supportive infrastructure. And this is how we can meet the needs of everyone without vastly overstepping ecological limits. Because if we are going to meet our climate and ecological goals with less of a reliance on these kinds of technologies, we need to be collectively reducing our energy consumption, not just our emissions footprint, but our energy consumption. Because by reducing your collective energy consumption, that is how you make it easier to reach 100% renewable energy with less pressure on biodiversity, with less space for human rights violations, and with less of a need for these kinds of technologies as well. So what does this mean, shifting from individualism to mutually supportive infrastructure? I think it means public transportation and walkable cities, the right to repair, better access to recreation and flexible work schedules, and paring back consumerism so we're not wasting as much in our day-to-day life. And the third shift, which ties back to the second, is shifting from fossil fueled empire to global repair and justice. This means undoing both energy access and wealth disparities between the global north and the global south. There's no other way to meet our climate goals while meeting the needs of everyone. It's that simple. It's also an ethical imperative. Countries like the United States have caused so much harm around the world. The legacy of imperialism has wiped out entire languages and cultures, and we cannot allow that to continue. North-South climate debt payments, anti-imperialism, and degrowth in the global north are all potential ways of getting there. And these three different shifts, those aims, are inherently political and pro-worker because they entail a transfer of wealth and power. I would say such framings for the climate crisis might be perceived as radical, but they're not especially new. The idea of climate debt payments and the return of indigenous lands to indigenous peoples were actually central facets of the Cochabamba People's Agreement, which was adopted in 2010. Now, a lot of people are unfamiliar with the Cochabamba Summit, which occurred in 2010, but this summit was sort of an alternative to the UN annual climate convention, but it's a people-powered grassroots bottom-up version. The Cochabamba Summit convened more than 30,000 people from over 100 countries, and its people's agreement has remained a cornerstone of some resistance movements. So I'll end this by saying that something you hear a lot from proponents of techno-solutionism and CO2 disposal is that it's impossible to meet our climate goals without it. But I believe that it's also impossible to meet our climate goals by relying primarily on technology as the cure. Techno-solutionists want you to think that their way is the rational way and that rationality points the way we need to go. But it's simply not true, because under current constraints, both of these visions, both the techno-solutionist vision for saving the climate and this people-powered version that I've laid out, are just as impossible. And I don't mean that to be bleak, because really my takeaway is that we can and we need to strive for what seems impossible today and yank it into the terrain of what really is and can be possible. And the way to do that is organizing and building power and building new forms of mass democracy that give people a seat at the table. Otherwise, we're not getting anywhere at all. And to me, this is how we'll build the world we want our descendants and other species kin to have. So that is the end of what I've prepared. And we have 15 minutes left for folks to ask questions, and I can talk about really anything at all about the project or the talk.
There was a question from Cliff in the chat a while ago. I can read it out if it's not accessible to you. It says, how would trillions of tons of CO2 supposedly be absorbed by the oceans? How would it affect marine life?
You know, so this is a really interesting question, and it gets to how an idea like CO2 disposal makes sense from a certain narrow engineering perspective, because every year the ocean ends up absorbing a lot of CO2 from the atmosphere already. So the concept behind CO2 disposal was essentially that you're cutting out the middleman. It's that like all this CO2 that we're putting into the atmosphere is warming the planet, and then it gets absorbed into the atmosphere over decades or hundreds of years anyway. So what we're doing isn't actually changing the amount that goes into the ocean. You're just cutting out the middleman. But of course, if we shifted to renewable energy, then we wouldn't have it in the atmosphere or in the ocean. And you're right, Cliff, that the sort of ocean acidification that it could cause is the same ocean acidification that we're getting from climate change. And what scientists were concerned about at the time of this research as well was the local impacts, because if you're dumping CO2 by pipeline into the ocean, the local impacts of that on like any sort of marine life were really not clear. I see another question in the chat, and I'll read it aloud. If folks have more questions as well, raise your hand, or you can write it in the chat too. And this question is that I read in the introduction about your choice to depict the green man motif and how it's been found all over the world, but most commonly observed in medieval European architecture. I would love to hear you elaborate based on your personal experience during research and how you reached that choice. Does this relate to any travel or field work I've done or observed? So I actually haven't done much travel or field work related to the green man. I'm looking around to see if I have a book with me. I don't, but there's a community of, there's sort of this community that has developed around the icon of the green man. It's a very mysterious and mystical icon because it does appear mainly in medieval and European architecture and dates back centuries, but it's not only found there. It seems like an icon that appears across several different cultures. But to me, the reason that the green man was so fitting for this project is that some folks interpret the green man as a symbol of humans and nature working together in harmony. But others see the green man and they see it as a symbol of the inevitable downfall and ruin of mankind, sort of a reminder of our death, like a memento mori. And they point to the fact that the green man on the surface maybe is laughing, but other times the green man really looks like he's in agony or anguish, and there are just leaves growing out of his mouth, growing out of his face. And I actually had never even heard of the green man until researching the MIT CO2 disposal conference. And at that conference, the organizers handed out award certificates for the best research that were called the Green Man Awards. So it's just like too perfect of an analogy. Seth, do you want to unmute and ask your question?
Yeah, there's a plane right now. Sorry if it's too loud, but I guess I'm asking, like, in all this research, there's so much bogus carbon capture, and I wonder what you think, like, projecting out into the future, once we've handled the fossil fuel industry and they stop emitting, what about what's already been emitted, right? Like, I'd be surprised if we haven't already gone over the carbon budget that would limit to 1.5 degrees of warming. Have you seen, or like, do you personally have a vision for like a version of carbon capture or drawdown that isn't a false solution, and like how that could, be integrated? You did a great job like explaining like the prescription that you'd have to kind of fix the climate crisis, and I loved hearing that. It's like, yeah, where does carbon capture fit into that in a good way, rather than this false solution, fossil fuel industry extending way that you outlined?
Yeah, I mean, I really don't know how we get to the point where CO2 drawdown technologies are in the hands of the people and can be at the behest of mass democracy, are cited in a way that really limits its impacts on communities. But I think that's where we need to be. The writer Holly Jean Buck has done a lot about this, although she's maybe a little bit more gung-ho about CO2 removal and direct air capture than I am. But Holly Jean Buck writes a lot about this idea of sort of people taking over the means of production for CO2 removal and making it into a sort of like public service or public commodity, public infrastructure, like water utilities, something like that. And I do think that there is, a need for it. The message in this book is not that like we can fully solve our problem without CO2 disposal or direct air capture. But I do think that the scale of it is just vastly, vastly overblown. It's been used as a tool for so long that if we fail to grapple with its roots and the power dynamics that it fits into, then we're just destined for complete and utter failure. And I also think that like nature restoration is super important, and that's a way of drawing CO2 down from the atmosphere, but has its risks as well and fits into different power dynamics. Reforestation projects and offsets have also had a lot of poor knock-on effects. That's a great question, Seth. Cliff, I like your comment about having read this in conjunction with another book about handling nuclear waste. I had never really thought about energy systems and the climate crisis and waste management together before working on this book. Jessica, do you want to unmute and tell me about phytomining? Because I haven't heard of it.
Yeah, it's a weird word, but basically there are a couple of companies that are using plants that are hyper accumulators of metal. And so they can create a farm that then the plants suck up, often they can be used as remediation of a spoiled environment, but they also have the ability, these particular plants, to hyperaccumulate metal, and then they can actually harvest the plants, process them into metal ore. So things like nickel and other metals that are needed by the battery and electric car industry. I'm just asking because sometimes things are too good to be true, and there's often hidden downsides that aren't necessarily published when there's a new development like that. Or maybe it is great. I don't know.
Has anyone else done research into phytomining or know about it and want to chime in?
I've read a few articles on it, and it seems really cool for remediation, but not really like an actual source for materials at scale. So it's kind of like, yes, it can do 2 out of the 3 things, but the fact you could somehow make our excessive need for precious metals part of the a circular natural system is kind of seems to me like fantasy, but I'm not sure. Yeah, but I think for like a Superfund site that's super contaminated, if you find the right plants and you can plant them there on rotation for X number of years and bring the place back to some better benchmark that's not totally contaminated, that's, in my opinion, that's worth it. But I'm not sure if industry would get behind that as yeah, we'll stop nickel mining and we'll just use these plants forever.
I think there's also what this makes me think about is how climate change and the climate crisis is such a global scale issue that it totalizes solutions and how we view them. as needing to be at the same scale. And like climate models, the sort of models I was talking about earlier, they're an example of that, where like the sort of CO2 removal that occurs in these simulations is bioenergy, carbon capture and storage, and just like billions and billions and billions of tons of this one technology. And when we examine and assess technologies, we're usually thinking like, is this technology feasible at global scale? But it does make me wonder, you know, like, can we actually be applying technologies at a smaller scale, or like entrusting communities or, you know, states, counties, cities to figure out their own way of maybe contributing to this global scale problem with more boutique, smaller scale solutions? I don't know. But yeah, it sounds interesting. I want to look into it more. Well, thanks everyone so much for joining. If you don't have the book and you want the book, I would just plug it again. You can order it online. I wonder if there's a link we can throw in the chat for folks.
I believe there's one on the website for the event. Let me grab it. So everyone, thank you so much, Andres. That was really great. And I also want to welcome everyone here while we're here together to look at our upcoming programming and index. There's some really nice community events that are open to all. There's a collective reading with Sam Taylor and a collaborative drawing. So if you like sort of the drawing styles here, maybe you can also participate in a drawing collaborative workshop next week. And I'm really happy that we're all here, and thank you for joining.
Yeah, thanks everyone for joining in today, taking an hour out of your Friday. Really happy to be sharing this work with you.